In this section, we're finding a trigonometric function of any angle. Previously, we're finding the values of acute angle. Now we're looking at obtuse angle. Here, theta is in the second quadrant on the terminal side. We have a point xy that is r units from the vertex. R from our Pythagorean theorem is equal to the square root of x squared plus y squared. Our definition of sine based on this angle is y over r, and cosine is x over r. You will see that if r is equal to 1, then this goes back to our unit circle, and sine theta is equal to y. Similar to cosine theta would be equal to x. Over in this situation, r is not necessarily equal to 1. Cosecant of theta is equal to the inverse of sine, so this becomes r over y. Secant of theta is the inverse of cosine theta, so this is r over x. Tan is sine theta divided by cosine theta. This reduces to y over x. And cotan theta is the inverse of tan theta, so this becomes x over y. In this example, we're going to determine the exact value of the sixth trigonometric function of this angle theta, which has a point on the terminal side, -12, -5. We know that r is equal to the square root of x squared plus y squared, so this becomes 144 plus 25, which is 169, and the square root of 169 is 13, so r is equal to 13. We know sine of theta is equal to y over r, so this becomes -5 over 13. Cosine of theta is our x value over r, so this is -12 over 13. And tan theta would be sine theta over cosine theta, so this becomes a positive 512. Our cosecant theta is the inverse of sine theta, so this is -13 over 5. Secant theta is the inverse of cosine theta, so this is -13 over 12. And cotan is the inverse of tan, so this is 12 over 5. Recall from our previous section that we said in the first quadrant, all trig functions are positive. So sine, cosine, tangent, and their inverse are positive. In the second quadrant, only sine and its inverse is positive. Everything else is negative. In the third quadrant, only tan and its inverse is positive. Everything else is negative. And in the fourth quadrant, only cosine and its inverse is positive, and everything else is negative. With that information in mind, and our knowledge of finding any trig function, we should be able to evaluate this problem. Here they're asking us to find the value of the sixth trig function of theta with the given constraint. So here we're told that tan theta is equal to -15 over 8. Now because tan theta is equal to negative, that means we're either in quadrant 2 or quadrant 4. Our constraint is that sine theta must be greater than 0. Sine theta being greater than 0 means that theta must be positive. Where sine theta is positive is in the first and second quadrant, so our angle then must be in the second quadrant, because that's the only quadrant that fulfills the condition where tan is negative and sine is positive. We know from our identities that tan is equal to y over x. From this we can find r. R is equal to the square root of y squared plus x squared. 15 squared is 225 plus 8 squared is 64. That's 289, and the square root of 289 is 17. Now that we have r and x and y, we should be able to find all six trig functions. We know sine theta is equal to y over r. So this becomes 15 over 17. And since it's in the second quadrant, we know sine is also positive. Cosine theta is equal to x over r. So this is 8 over 17. Or because cosine is in the second quadrant, it's negative. In our third quadrant, we have theta is equal to -15 over 8. Cosecant theta is the inverse of sine theta, so this is simply 17 over 15. Secant is the inverse of cosine, so this is be negative 17 over 8. And cotan is the inverse of tan, so this is negative 8 over 15. In this section we're looking at reference angles, and a reference angle is acute angle theta prime formed by the terminal side of theta and the horizontal axis. So here in quadrant 2, this is our terminal side of theta, and the acute angle between here is theta prime and is known as our reference angle. To find the reference angle in the second quadrant, since our angle here is pi or 180 degrees, it will be 180 minus theta or pi minus theta in radians. In quadrant 3, here we have theta all the way here. Our reference angle, this acute angle between the terminal side and the horizontal axis. So theta prime, or reference angle, is theta minus 180, which will give us this side, or theta minus pi rad. In the quadrant 4, theta prime, or reference angle, will be equal to 360 degree minus theta, or 2 pi minus theta to give us our reference angle. In this example, we're going to find the reference angles theta prime and sketch theta and theta prime in standard position. Our first example, we have theta is equal to 160 degrees. Since it's 160 degrees, we know it's in the second quadrant. So our reference angle theta prime would be equal to 180 minus 160, which is 20 degrees. So here our reference angle is 20 degrees. Sketching it in standard position, this would be theta 160 degrees, and this would be 20 degrees, or theta prime. In this example, we have 125, negative 125 degrees. That means our angle is being measured in a clockwise direction, this way, which means our angle is actually in our third quadrant, go in this direction. So here we have theta. Now because theta is negative 125, our theta prime would be 180 minus 125. So here 180 minus 125, which would be 55 degrees. So theta prime here would be 55 degrees. In this section, we're going to be using reference angles to find the sine, cosine, and tangent of an angle. The use of reference angle is that the reference angle, value of the reference angle, is equivalent to the sine, cosine, or tangent of that same angle. So here, we're trying to find the sine, cosine, and tangent of 300 degrees. The reference angle for 300 degrees will be 60 degrees. Since it's in the fourth quadrant, it will be 360 minus 300, which gives us 60 degrees. We know from our unit circle that the sine of 60 is equal to the square root of 3 over 2. The cosine of 60 degrees is equal to 1/2. And the tangent of 60 is equal to the square root of 3, since it's sine over cosine. As we mentioned before, reference angles are equivalent to the original angle. So here we know that sine of 300 is equivalent to the sine of 60. However, we need to keep in mind the quadrants. We know 300 degrees is in the fourth quadrant, so the sine of 300 must be a negative. Therefore, the sine up here would be negative square root of 3 over 2. Similarly, the cosine of 300 is equivalent to the cosine of 60. And we know that in the fourth quadrant, cosine is positive, so 300 and 60 are equivalent. Tan of 300 is the equivalent of its reference angle. However, in the fourth quadrant, tan is negative, so this would be the square root of 3, negative square root of 3. So we can find the reference angle and use the sine from their corresponding quadrant to determine the exact value of that angle. In this example, we're going to find the value of cosine theta, given that sine theta is equal to -3/5, and we are in the fourth quadrant. We know from our identity that sine theta is equal to y over r. So therefore, we know that x is equal to the square root of r squared minus y squared, since r squared is equal to the square root of x squared plus y squared. From this we have r, which is 5 squared minus 3 squared, so that's 25 minus 9, that's 16. Square root of 16 is 4. So here we have r is equal to 4. We know cosine theta is equal to, we know cosine theta is equal to x over r, so cosine theta here is equal to 4 over 5. Now because it's in the fourth quadrant, we know cosine theta is positive, so this is our final answer. In this example, we're solving the equation cosecant theta is equal to 2 radicals 3 over 3. We're asked to find two solutions, and we're given our answers in degree. And we know that theta is in between 0 and 360 degrees. From our identities, we know that cosecant theta is equal to 1 over sine. So if we find the inverse of this, sine theta will be equal to 3 over 2 radical 3. If we rationalize our denominator by multiplying by radical 3 here, we get 3 radical 3 over 2 times 3, which cancels to give us radical 3 over 2. So sine theta is equal to radical 3 over 2. We know from our unit circle that sine theta is equal to radical 3 over 2 at 60 degrees. So one of our possible solution is theta is equal to 60 degrees. We also know that sine theta of 120 degrees is also equal to radical 3 over 2 positive. Since sine is positive in both the first and second quadrant, our answers are 60 degrees and 120 degrees. In this example, we have a plane flying at an altitude of 6 miles. It's keeping parallel to the surface of the Earth. It's going to pass above an observer. So the observer is the distance away from the plane. We're required to find first the distance when theta is equal to 30 degrees, and then when theta is equal to 90 degrees, and part C when theta is equal to 120 degrees. Since we're given the altitude and we're trying to find the distance, here we have the opposite and we're required to find the hypotenuse. We will use the sine function because we know sine is equal to opposite over hypotenuse. So the sine of 30 would be equal to the opposite, which is 6 over d. We know from our unit circle that the sine of 30 is equal to 1/2. So 1/2 is equal to 6 over d. From that we have the distance from the observer to the plane when at an elevation of 30 degrees would be 12 miles. When theta is equal to 90 degrees, the plane is directly overhead, so the distance from the observer to the plane will be 6 miles. In part C, theta is equal to 120 degrees, so sine of 120 is equal to the square root of 3 over 2, which is equal to, once again, 6 over d, which gives us d is equal to 6.93 miles, but our angle of elevation is 120 degrees.